This chapter considers more complex ideas about functions. The notation is the first thing to sort out. For example, f stands for a function. The first line is read as f is the function that maps x onto x squared. It means the same as the second line, which we read as f of x equals x squared. The third line shows another way the notation is used. We read it as f of minus 3 equals 9. We have substituted minus 3 for x in the function f and worked it out as 9.
Describing functions in this way is quite powerful. We shall look at some of the ways it's used. The first is in the context of inverse functions. Remember, an inverse function takes you back to where you started.
For example, we shall find the inverse function for f. F multiplies x by 4, then you add 3. The reverse process is to subtract 3, then divide by 4. Dividing by 4 is equivalent to multiplying by a quarter. The inverse of f is shown by f with a superscript of minus 1. F to the power of minus 1 is the function that maps x onto a quarter x minus 3. We can check that we have the correct function by starting with 5. We expect to arrive back at 5 after doing the function and then its inverse. Applying the function f, 4 times 5 plus 3 gives 23. To apply the inverse function to 23, subtract 3 from 23, then work out a quarter of the result, takes us back to 5.
We can also put functions together by doing one function followed by another. This is called composing two functions, and so you get a composite function.
For example, we have two functions. F is the function that maps x onto x squared, and g is the function that maps x onto 5x plus 2. G, f of x, equals 5x squared plus 2. We apply the function f first to get x squared and then apply g. We don't write all of the brackets, so gf means you do f first. To find fg of x, we apply the g function first to get 5x plus 2. Then we apply the function f, which means squaring. fgx equals 5x plus 2 squared. Notice we haven't written one of the pairs of brackets.
Remember that composite functions look as if they are in the wrong order, and that they are not multiplied. Let's do another example. F is the function that maps x onto 2x minus 1. F of minus 7 means we substitute minus 7 into the expression 2x minus 1. 2 times minus 7 minus 1 equals minus 15.
The superscript of minus 1 means we need to find the inverse function. F is the function that maps x onto 2x minus 1. So we have to reverse the function f. Reversing the function f means adding 1 and then halving. So the inverse function f minus 1 times x is half x plus 1.
Now we are looking for the composite function fg. They are written in reverse order, so we need to do g first, which gives us x squared. Next, we do f. We multiply x squared by 2 and subtract 1. So fg of x equals 2x squared minus 1. Remember, a superscript of minus 1 means the inverse function, and two letters together means you do the second function followed by the first one.